Hey everybody, Lars here. Today we're going to get started with Unit 3, okay? Unit 3 is not like the other units we've been going through. Unit 3 is longer. It's a 3-week process, not a 2-week process. But as you can see, if you've already seen the slides, and I hope you have, it breaks down kind of neatly into 3 different topic areas. The first is functions, and then the second is file I/O and doing input and output with files. And then the third part is using libraries and importing things and using things. They're all related, though, in a larger sense, because they really speak to what I call modularity or compartmentalization. We're at the point now where you're going to be tackling problems that are a little more complex than add 100 numbers together or give me the square of ABC. We're going to have to start taking our problems and breaking them down into smaller sub-problems and then solving them all and doing what problem solvers do. So functions and taking things and putting them in libraries and modularizing your code speaks to that. It really allows you to have a system that makes more sense and break things down into smaller units so it's more understandable as a programmer and a problem solver. I know, as this unit goes by, you're going to have that eureka aha moment. You're going to say, oh, okay, now I get it. I know why we're doing this. This is why we're doing this. This is actually clever. This is going to work. All right? But today, I just want to really quick go through functions. I always say really quick, and it's not really quick, but really quick. Let's go through functions. I already prepared a file for us. I called it myfunc. And as you can see right there, I just put my comments up there. You've already been dealing with functions, okay? Real quick, as an example, I'll just say my list, and I will say print sum my list. I don't know if I told you or not. In the past, some students have used sum for a variable name, and I tell them not to do it. And this is the reason why. Sum is a built-in function in Python. You can see if I run my code, it gives me 21. It sums up any, what we call in Python, an iterable, which a list is. It's something you can iterate over. Okay, so any iterable will be summed up by the sum function. Another function that you've already seen is type. I did my list. Okay, it tells me it's a list. It says class list. You're going to know what that means in Unit 5, okay? Basically, what we're doing is you have the name of the function, sum, type, and then you have an argument, which in this case is the list. So I'm giving the function sum my list to do something with it. Same with type, do something with it. The return value, the third component of the function, is over here. 21 is the return value of the sum function. It's the sum of the items in the list. If I want to know the return value of type, it tells me what type of data type I have. In this case, class list. So I'm dealing with a list. So this, is an example of the 3 main components of a function: the name of the function, the argument list, and then the return. But we're really more concerned with creating our own. Well, actually, before we create our own, let me go. I think I have it on the. Yes. You can go to the online Python documentation. I actually have the 3.4 up, and look at all of the built-in functions that are built into Python ready for you to use. Now, later, if you've read all the slides, you're going to get to the third part where we're importing from other libraries, be it the standard library or third-party libraries, but that's not what this is about. These are built-in functions. These are loaded and ready for you to use once you start using Python. And as you can see, you've already seen some of them. There's input, which you've seen. There's integer, all of the casting functions, string, float will be here. Len, which some of you have used already to do a little extra credit. Wink, wink, nod, nod. So this is where all the built-ins are. You can look them up and see what you have available for you when you're a Python programmer. All right, this I am going to, what am I going to do with this? You know what? I'll leave it. But we are going to move on and create our own function. So let's say I want a function And in the past, I've written a function called multi-square, but I think today I'm going to do one called multi-cube. Let's say that I want a function that takes two numbers, multiplies them together, and then returns the cube. So if I had, say, 2 and 2, I would send it to my function. 2 times 2 is 4, and then 4 cubed is what? 4, 4, 16, 4, 64, yeah? So it would return 64. We'll actually do that one when we're done, all right? So what do we do if we want to create our own function? First thing we're going to do is we're going to type def. Define, definition. It's what we put in when we're telling Python we're about to create a function or a variable that runs a block of code. And you're going to see we also use it in other places. But this is what we do to create a function. So I'm going to define a function called multi-cube. The multi-cube is going to take two variables. I will call them, I could just say A and B. I don't want to do that. Not very much more descriptive, but I'll say num1 and num2. All right, so I'm creating a function called multi-cube, and it's going to take two numbers. What am I going to do with those numbers? The first thing I'm going to do is get their product. And I'm going to show you later we can do all this in one line. Then I'm going to return, and I always misspell return, A cubed. Okay? So now what do we have there? We have a function called multi-cube. I give it two numbers. We're going to give it 2, and then we'll give it 2 and 3. It multiplies them together and returns the cube of that number. So let's use that and see what we're all about. Now, and I'll go through this because I'm going to trace the code, so don't worry about it. Let's say my answer equals multi-cube 2, 2. And I'm going to print answer. Now, I believe, if my math is still with me, it should be 64. Let's find out. Yay, it is. All right. Let's trace through exactly what this code did. I tell Python to run the code. It starts up here, and it ignores these things because they're comments. As we know, it has read this in as one big string but doesn't do anything with it. It acts kind of as a comment for us Python programmers. Python sees the DEF, that it's defining something called multi-cube. So it reads in multi-cube. It actually uses it as a variable name, or what we used to call a handle, and it saves it in memory. And says, when this is called, I have two variables, I will take them and I will perform all of these code, all of this code. But this is only saved in memory. Nothing is run yet, okay? That def means define this function, but we haven't used it. So I drop down to main program, comment, I don't do anything. The first real steps we take are here when I take the variable answer and I assign it the result of a function call. So here, for the first time, I call my function, and I give it the numbers 2 and 2. So what happens? We call it in memory, all right, but here it's up here in the beginning of our program. This 2 is assigned to num1, and we'll discuss that in a second. And this 2 is assigned to num2. I create a variable called A. It equals num1 times num2, so 2 times 2 is 4. A will equal 4. And then I return 4 cubed, which in this case is 4 times 4, 16. 16 times 4, 64. So I get 64 over here. Okay? But I've just returned it to this line, and it puts that value in the variable answer. All right? And then I print with the last line of code in this program, I print answer. So that's why we get the 64 down over there. All right? So that's the trace of what we're doing, and we could actually change it to a bunch of things that I'm not going to know the answer. There we go. We get 216 for 2, 3. So 2, 3 is 6. 6 cubed is 36 times 6. All right, that makes sense. All right? So that is how the function is defined. We have the name of it, the definition. We have the arguments, the two variables we're going to use. And we have the return value, which in this case is the cube of A. Now, In this instance, there's two things we really want to talk about right now. Just because I want to cover it and I want you to understand it. The first thing is called scope. Okay? Scope is the situation where when we do functions in computer programming, there are two different ways to pass values or variables to a function. In this case, you can see we're calling multi-cube with a 2 and a 3. And to the 2 and the 3 are going up to these variable names, okay? There's two different ways we can do this. In some languages, you pass variables by what's called reference, where these variables would point to these actual numbers. Actually, there's a better way to do this. A equals 2, B equals 2, and we will call answer for A and B. And you'll see if we run it, there's no difference. Everything is good right there. And if we pass by reference, num1 and num2 will merely point to A and B. So if we alter them in our function, the real variables will be altered. But that's not the way Python does things. Python does things another way, which is called passing by value. And what Python does is when you come up here to the function, it creates two new variables, num1 and num2, and places the values of these into those new variables. So you will see, we can actually take a look and see if you change these variables in the function, the original values are not changed. All right? But because we do things that way, there's an additional little piece of baggage that comes along that we're going to look at right now. I call multi-cube AB, and it comes up here. Num1 is A, num2 is B. I run this, and I get A, and I return A cubed, and I print it out, right? Let's say I go down here, and I want to print A. What do you think A is? Okay? A was num1 times num2, so A should be 4, right? So if I run this program, I should get 64, which is my answer, and then print A, which is 4. So let's run that. Why? Oh, no, I don't want A. Oh, boy, that scared the hell out of me. I'm like, what's going on? I use the same variable name here, so I'm a dope. What I should do is actually use num1. So what is num1 in the function? Good Lord. What is num1 in the function? I hope I didn't confuse anybody. Num1 is 2. Okay? So let's print num1, and it should print 2. If this prints out, I'm in a lot of trouble. And I'm not. We get an error. Now, why do we get that error? It says down here, num1 is not defined. But clearly, num1 is used up here. This is what's going on. In scope, with a function, I've created two variables for use in my function. But when that function is over, those variables go away. They're out of memory, they're gone, the function has done its job, returned its value, and gone away. I'm actually going to use C for that, just so we stay away from our original variable names. Because I'm going to save this code, and I'm going to put it up on the web for you, and I don't want you running into the confusion we just ran into when I give you the code. So we're going to call it C. So if I tried to print that C, I'll show you again with this. We blow up. C is not defined. And the reason C is not defined is because once this function runs, all these variable names go out of memory. They're gone. Okay? So that is part and parcel of what's called scope. The function is like a mini program off to the side. And we go and we run it and we get our value. But after it runs, it's out of memory. It's gone. Okay? Sorry about that bizarre instance right there. So, basically, if I wanted to print C, I could do it up here because I'm still in the program, okay? Now I print 4 when I'm in the function and everything is fine because C exists in the function. But if I try to do it outside the function, things do not go so nicely, okay? So that's scope. Remember that. In Python, we pass variables to functions by value. So we're making copies that we use in our functions. And after our functions run, all those variables go away and can't be accessed out here in the main program. And that's a concept in computer programming that we basically call scope. Wherever you're currently running is called the local space, and the big overall program is what's called the global space. And when you run a function, you're in a local space, and global doesn't know what you're doing. It's just waiting for a return variable. All right? The second thing we want to go over real quick when we talk about functions is this. Okay, what do you think is going to happen if I run this code right here? Let's find out. All right, the answer is nothing. As you can see, it ran. I didn't get an error, but nothing printed out and nothing really happened. And the reason is because in this main program, I don't really print anything, nor do I take the results of this function and save it to a variable. And that's the point. Fruitful versus void. If you remember from the slides when I printed out the first 4 lines of that KISS song, that was what's called a void function. Void functions usually don't take arguments, usually don't have return values. They never have return values, voids. They just do a series of commands, and when they're done, and then you return control back to the main program. Well, in this case, multicube, we've created a fruitful function. We've created a function that has a return value, so it creates something. The problem is we've got to make sure we capture that something. And in the context of what we've been doing so far, we've got to do one of two things. We've got to either print it so that we can see it. So if I did print multicube AB, that would be fine. Or what I usually recommend, oh boy, I'm not using C. I'm not going down that rabbit hole again. Then there we go. Up, up. Or we can capture it in a variable. And then if we want to look at it, we can print our variable. Okay? But you always have to be aware that when you're using functions and you're using a fruitful function, you need to capture that value when it returns. Because if you just run it out in space, I mean, you can come out here. This should work. And run it, and you will get the value. But that's because this is the command window where we check our variables and we do our things. In the context of running a program, you've got to use the print, or you've got to capture it in a variable. Okay? So be aware that fruitful functions return values. Those values need to be captured. They can't just be run in space. Okay? There is one more thing I want to do, and I don't know. I don't think I'm going to do it in this program. I think I'm going to save this, myfunc.py. And let me make sure the variable names are different. What a mess. All right, they are. So myfunc.py, I will put up on Sakai for us. But for now, I'm going to grab a new file. And I'm going to say this is a comment. And then I'm going to say author Lars. And then I'm going to say a better way to tackle Euler 6. All right. Do we remember Euler 6? I think it was the last video I did. It was like a week ago. It's been so long between videos. Euler 6 was the problem where we went and we saw that the square of the sum minus the sum of the squares for a certain amount of numbers, either 1 through 10, or then we did 1 through 100. We want to find the difference of those two particular things. So we wrote a program with loops that went through the numbers from 1 to 100 and squared them and then added them to an accumulator, so we got that number. Then we ran through another loop and we added up all the numbers from 1 to 100, and then we squared that result, and then we used just in the print line, we took their difference and we got the answer that we wanted. But is there a better way, a more computer programmer-like way to tackle that situation? There is. Now we have functions in our toolbox, so we can use functions to attack that problem a little bit better. So when I, as a programmer, am presented with that problem, I don't see a single problem. I see three problems. I see the first problem is find the sum of the squares. I see the second problem as find the square of the sums. And then I see the third problem is find their difference. So let's break it down and compartmentalize and do things problem by problem. The first problem is I want to find the sum of squares. So let's write a function that does that. Define sum of squares. I am going to take a limit called n. So if I give the function sum of squares 10, it'll do 1 through 10. If I give it 100, it'll do 1 through 100, and so on and so on. So what do I want to do? For I in range 1, comma, n plus 1, remember, it's the first thing we don't want. I am going to, I'll call it s. S plus I squared. Yeah, it would help if I sent back what I did. Return S. All right, I like it. I think that's right. Wow, we can test it. Print SOSQ10. Oh, that'll make me save. All right. Might as well put it where it's going. 3 code. I will call it new Euler.py. And I will save this for you guys. If I run it, oh, hello. I will explain this. Remember, Python evaluates expressions from right to left. So when I got down here, I said S plus I squared. Python said, what is S? Because it had never seen it before. So if I define it there as 0, now I can use it, and it can start looping around as an accumulator. And I was right. So that is 385. And if memory serves, that's correct. Okay. So I now have a function that does sum of square for a number I give it, from 1 to whatever number I give it. Pretty cool. What else do I need? I need square of sum. I'm going to do it the same. You know what? Watch this craziness. Oh, didn't want to do that. All right. Now, with just a few changes, square of sum. No. Let's see. Square of sum. And I don't want to do that. I want to make it an accumulator, and I want to do it here. Yeah? Yeah? You think? Let's print. Print. Square of sum, 10. Yeah, look at that. Look at that. All right, cool. Well, let's go explain it. Now, my second one, square of sum, I went and I grabbed all that code because it was really only 2 changes. I changed the name of the function, and then I came down here, and I want to just have a regular accumulator that adds everything in the range so that I get the sum, and then when I return, I square it. Because that's what I want. I want the square of the sum. Here, I wanted the sum of the squares, so I had to square them as I was going along. I mean, as you can see, they're different numbers. But here, I want the square of the sum, so the first thing I do is I find the sum, so I want a regular accumulator, and then I just return the square right there. Okay? So now, I have a function that does sum of square, and I have a function that does square of sum. So what's the last thing I need? And I can do it in a print statement. The difference is, do a little semicolon. What's the difference? The first thing I'm going to do is square of sum for 10 minus sum of squares for 10, right? And that should be it. 2640. All right. I think That's correct. For 10, let's do it for 100. I know I could put it in as an input statement. And we get 251, 64, 150. Just to be sure. The project. Euler.net. Remember, it's .net, not .com. Don't be fooled by imitations. I will sign in. Hey, I will sign in as us, because that is the last time I was here. 59204. Sign me in. Sign me in. All right, and now I'm going to go to number 6. And because we've done it already, number 6. How about going to? Oh, no. That's not number 6. That is the 6th rack of things. All right, there we go. And there we go. 251, 64, 150. And the value I got back here, 251, 64, 150. So that's correct. So we have now, and I believe it's shorter than the other one, might not be, but we have rewritten the solution to Euler 6, but we've done so with functions. Now, the interesting thing about this is that now that we've done it this way, we never have to write that code again. As you know, if you've read forward to the third part of the unit slides, we can put this in our very own library, and we never have to bother again in our lives. We got that sum of square thing handled, okay? Because I can take that code, and I can put it in my library and always call it. So the only real thing that's running here is this last line here. All those other functions I have waiting for me, ready to use at a moment's notice. So technically, this is a better way to attack the problem because we compartmentalized. We took 3 different problems and we spread them out into different things, and we wrote functions to solve them. Okay? So that is part of what we're talking about when we're talking about functions. We want to start compartmentalizing and doing things in modules so that we take big problems, turn them into a series of little problems, and then solve those little problems. And that's what we do here. Okay? So this, to my mind at least, is a better, more Pythonic way to tackle Euler 6, and we never have to worry about any of those mini components again. We've written code to solve those things, all right? Okay, so that's functions. Usually made out to be a lot harder than they are. They're not that difficult. Just think of them as mini programs. And going forward, probably tomorrow I'll give you assignment 1, and you'll see it's just a function to manipulate numbers and see whether they meet certain criteria or not, and then return true or false. You'll see it. It's called a harsh add function. If you want to look ahead, go look up what a harsh add number is, because I'm going to give you that assignment tomorrow. Okay? So that's functions. Use this video, read your slides, read the Zell. Functions are not difficult to create. Where the magic of functions comes in is when you get a problem and you recognize when to use them. And you will. It's not hard. You're going to see. You're going to be using functions from now forward, and you're going to like it, and it's going to make things a lot easier for you. All right? Announcements. Hopefully in the next couple of days, I will be releasing assignment 1 so you can get going on that. But you need to be not worried, but aware that in a couple of weeks, it's going to be March, and your midterm assignment is going to be due. So make sure you do some work on that. It's, going through the steps in Learn Python the Hard Way or Code Academy. It's a little time consuming, and it's going through the basics, but it's good practice for you guys. And I want you to think on the higher level. I want you to think, okay, as far as online resources is concerned, I'm watching lectures at MIT. I'm going through the different Code Academy steps, and I'm doing things that way. I'm also doing things to learn Python the hard way, and don't cut and paste. You know what they tell you. Make sure to type all those things in yourself. Go up a level and think to yourself, okay, do I like this? Is this a good way to learn? Am I learning things? Think about the process that these different resources are making you go through, and what you think about that process, and if you think it's a good way for you to learn or it's not a good way for you to learn, okay? Go through that. As far as this unit is concerned, it easily breaks down into the 3 different parts, right? this first part that we reviewed in this video, functions. The second part, which is file I/O, look for in the middle of next week. I'm going to do a video on file I/O. The third part, probably next weekend, I'll get you a video on modularity and using libraries, not just the standard library, and not just importing third-party modules like Matplotlib or Pygame or NumPy, but also creating your own libraries and creating your own modules of code that you've made. I would take square of sum and sum of square and put them in my own little utility module so that I have them to use later when I write code in the future. Things like that. So the overarching theme of this particular unit is modularity and compartmentalization. And as you're going to find out as we get to the end, this is it. This is the basics of imperative Python. And then moving forward, it's going to be less learning Python and more using Python. And you're going to learn as you have to use it to tackle things. Because Unit 4 is computer science topics, Unit 5 is object orientation, then Unit 6 is data structures. We're going to be using the Python that we've learned. Okay? The basics of these first 3 units are the basics of an imperative programming language. Then you're going to go and you're going to use them. All right? I'm not going to kill you with announcements. Just keep an eye on announcements when I send the emails, and we will keep things moving along with this unit. You guys, I think, are doing great. I've looked at some of the quizzes already, and everybody's doing well on the quizzes. Eric and Hans, who Eric and I are training to be the TA next semester because Eric is graduating. Eric and Hans are going to be looking at your assignments tomorrow and Monday, so hopefully I'll be doing something with sending you Unit 2 grades back during the week, and then eventually, as time permits and I get my schedule straightened out, I will probably do a couple videos for the 2 programming assignments. Because what you may have known or what you may not have known is that those 2 programs are actually famous programs in computer science. The CowPy was really a program called FizzBuzz that was just rewritten, and the second one was a modification on a famous program called the rainfall problem. And the rainfall problem has a big story behind it in computer science education. And that program was actually given as an assignment to students in Yale in the 80s, and they were unable to do it, which is kind of weird because if you're an experienced programmer, you're like, wow, that's easy. You should just be, be able to hop into a loop and wait till you see the sentinel and only add up the positives and blah. I gave you the negatives, but when it was done in the 80s, it was the positive. So we'll review all of that, and we'll go through all of that, all right? Make sure to use the forums. Go in there. If you have any questions, go in there and ask, okay? And I'm always available, via email, so you can send things to me too, all right? All right. You be good. Use some time over the weekend to read a little bit. Have fun too. Don't make yourself crazy. But use a little time to go through the Python stuff. And you know it too, because you can feel it. Slowly but surely you're learning. And you're learning. People are asking me good questions. Danica's been doing Euler problems and asking me how to do multidimensional arrays. And Chengzi has been, running into problems because he's doing statistics things on the side, and he named his program statistics.py, and he learned the hard way that you can't name your programs after libraries or you won't be able to load them. So I love what I'm seeing. You guys are doing good things. You're reading the slides and you're doing extracurricular stuff. It's really a good thing to see. All right? So you have a good weekend. I am out of here, and I will send an announcement in the next couple of days. Don't forget, I think a week from this coming Monday, 9 days from now, we're going to meet again in person. All right? So make sure that's on your calendar and make sure you're ready for that, okay? All right, cool. Then I'm going to get out of here. You be good. Any problems, you get on that Sakai site and you let us know about it, all right? Cool. Then I will see you later.